Hi guys, welcome to the channel. So today we are going to start with the topic of Woodward Fieser rules for calculating lambda max. So first we will try to find out how we are going to calculate lambda max when we have the alicyclic dienes or the dienes containing open chain system. Now what do I mean by that? It means where we have the basic unit of butadiene type of a system. So first, if we have some sort of a compound, we will try to find out if there is presence of any butadiene type of a system, that is this type of a system, right? In this case, the base value is going to be 217 nanometers, right? So this is the first rule in which we will look for alicyclic dienes such as like this butadiene type of a system, and here we will be having base value of 217 nanometer, right? Next, if we have homoannular conjugated double bonds, what do I mean by that? If we have a system like this, homo means same. So if we have this type of a homoannular conjugated double bond type of a system, another example could be like this. Here some miscellaneous groups are present. So this is also homoannular conjugated double bond type of a system. Here is the homoannular conjugated double bonds, right? So in these type of systems we will be having the base value of 253 nanometer. So if we are having this type of homoannular conjugated double bond type of a system, that is both of these double bonds are present in the same ring, then the base value is going to be 253 nanometers. Now the third rule is if we are having heteroannular conjugated double bonds. Initial was the homoannular and this is the heteroannular conjugated double bonds or the heteroannular dienes. In that case, conjugated bonds are not present in the same ring. For example, if we have a compound like this, or like this, or like this. In all of these compounds, the conjugated double bonds are present in different rings, right? So in these type of compounds we will be having the base value of 215 nanometers. So we have discussed about the butadiene type of a system in which we will be having 217 nanometer of base value. In homoannular conjugated double bond type of a system, base value will be 253 nanometer, and in heteroannular conjugated double bonds or heteroannular dienes like these, we will be having base value of 215 nanometer. Now next is the case of acyclic triene. So the example could be this could be one of the examples of acyclic triene, right? 3 conjugated double bonds are present here and the system is not cyclic one. So here the base value is going to be 245 nanometers. Now these were the rules related to the base value. Now we will look for the increment which is there with each type of substitution. So we are basically going to discuss about the increment for each type of substitution that is going to be present in any given molecule. So first we are going to discuss about the alkyl substitute or the ring residue. Now, what is alkyl substitute or ring residue? For example, if we have a molecule like this, this is the molecule. Now here, this is the alkyl residue which is there. So if we have any alkyl residue or ring residue, alkyl substitute or ring residue like this, for that we will add 5 nanometers, right? First we will look for the base value, and then we will look for the alkyl substitute. This is an alkyl group, right, which is substituted over here, or you can say the ring residue which is outside this ring. So for that we will add 5 nanometer. This is the first rule. Now second is for the exocyclic double bond. For each exocyclic double bond we will add 5 nanometer. Now what is exocyclic double bond? Exocyclic, exo means out, right? Out of the ring, whichever double bond is present, that will be the exocyclic double bond. For exocyclic double bond we will add 5 nanometer. This is the second rule. Now third rule is for the double bond extending conjugation. Now what do I mean by that? For example, if we have some sort of a molecule like this, so here what is happening, we have this system having some base value, right? From here we will calculate the base value. This is what? This is heteroannular type of a system. So for that we will take up the base value of 215 nanometers. Anyways, now looking for the double bond extending conjugation. Now this double bond over here, what it is doing is, it is extending this conjugation, double bond, single bond, double bond, single bond, double bond. It is extending this conjugation. Now for each double bond extending conjugation we will add 30 nanometers, right? This is the third rule for the substituents present in any given molecule. First we will look for the base value using those 4 rules, 4 or 5 rules, yes, 4 rules, and then we will look for the increment for each substitution with these 3 rules. Next will be the oxochromes. So now we will look for each of these groups present inside the or outside the molecule, or you can say along with the molecule. So first we will find the base value, then we will look for the substitution, right, increment for each substitution, and then we will look for the oxochromes. Now if OR group is present, then we will add 6 nanometers. If SR group is present, we will add 30 nanometers. Don't worry if you are not able to get how we are going to calculate using these rules. Once we are done with the rules, we will go for the questions. So we will solve the questions, and after solving the questions you will be able to understand each of these rules. So these rules will be much clear to you guys when you are going to apply those to solve the questions, right? So first we'll go with the rules. So next is Cl group or Br group. For these type of groups we will add 5 nanometers. For Nr2 group we will add 60 nanometers, right? For OCOCH3 group we need not add anything, right? These are the rules which are applicable for the oxochromes. Now these are some of the rules which we have to keep in mind while solving the questions. Now we will straight up move on to solving the questions in the next video. So using these rules we will solve all of these questions. We will try to solve at least 5 or 6 questions, and from those questions you will be very much clear with these rules, right? So stay tuned and thank you so much for watching.